Okay, you guys with me on that? You just solved right here. This is the solve. Now, what does a graph look like? Let's look at the graph. Okay, I put 0 here in the center. My reference number is -3. Where's -3 in relation to 0? Okay, -3 would be around here. I put my circle where it would be. I have to describe numbers, arbitrary numbers, x values, a lot of numbers that are what? Less than that reference of -3. Numbers that are less live where? Left. Good. So you're going to shade everything to the left. Exactly. So if you made a mistake, that's okay, because you're here to do what? To make mistakes. Remember, there's nothing wrong with making a mistake. If you're a human being, you're going to make mistakes. The best, or the most important thing is that you what? Learn from those mistakes. So you want to learn right here where you made your mistake. Okay, you okay with this? This is the what? The graph. What's the interval? Negative infinity. Up to? Good. Do I use a parentheses? Okay, good. If you graph this with a parentheses, is that okay? Yes. You look in the back of the book, you'll see that. Here's the graph. Here's the interval notation, and you also need what? The set notation. Well, you have it. It's a set of all x. Such that this is your what? Description. X is less than -3. So give them another check if they have the correct graph, if they have the correct interval, if they have the correct set. Yes?
The description is flipped as well. It would be a set.
That's okay. In other words, here's the issue. What if they have the description this way, the way they left it? Is that okay? Yes. But be careful. Did they do that? How did the graph look? Did the graph go the other way? Yeah. Exactly. This is, God, how did I know? Yes. Mark it, put a double circle. Mark it double wrong.
How sad.
Why? Why do I say this? See, ladies and gentlemen, like, when people leave typically the solution this way, and even though I say this to you, we're used to graphing numbers less than -3. Sometimes people get a little lazy about reading it. What I mean, we're describing numbers, real numbers that are what? Less than -3. You want to know what they do? They go, oh, I know. If it's pointing to the left, I'm shading to the left. Do you guys know that? And so when they look at this solution, what do they shade? To the right. Wrong. You guys, this is consistent. You can have both graphs representing the same thing. So they look at this, although it's correct, but they shade going that way. That's a very common error. So when I say give it a double circle or give it a double error, whoever gets it back, that should really sting. Why? Because the more it stings now, the less it stings on a what? Test. That's the idea. So you want them to fix that idea now. The only way you can fix things is by making mistakes. Okay, you understand what I'm saying? You got to make that mistake before you fix it, so you can fix it. You know, so you have to know you're making that mistake. Everybody else who made that mistake understand? Yeah. Exactly, that's the idea. Okay, good. Let's try this out here. Divide both sides now by what? By 2. Is that true? Let's see what happens. Your 2 goes away. You got x here. What does this mean? It's -8/5 divided by what number? 2. Let me really be clear here, because it looks a little funny. Yes, you're dividing both sides by 2. On the left, -8/5. Here's my fraction. Divided by, here's my division, what number? 2. Greater than, my 2's cancel, x. I have to do this work. We did this kind of work. -8/5 now, not divided by 2, but what? Times what? Good. Why 1/2? Because this here is over, this whole number 2 is really 2 over 1 as a fraction. How do we divide? Multiply with the what? Reciprocal. Keep the left fraction the same, multiply, flip the second fraction. That is still, by the way, greater than x. Okay, good. How do we multiply fractions? Straight across. We got negative 8 over what? 10. What do you simplify that as? Negative 4 what? Fifths. So you got negative 4 fifths greater than x. If you write it this way, is that okay? Yes. What's it also known as? X negative 4 fifths. Let's go through this. We're comparing negative 4 fifths with x. Negative 4 fifths and x we're going to compare. What does JAWS open to? It opens to the bigger number. What number is bigger? Negative 4 fifths. Is that true? So how's JAWS going to open now? To the negative 4 fifths still. So notice we were consistent that JAWS is still opening to the negative 4 fifths. And so I'm running out of space here because we're filming and this is, the camera's on. Let me go back now here and let's actually describe all of this. How do we graph this? Here's the solution. We solved this. Here's your solution. You got that. Give it a check. Here's 0. Where's negative 4 fifths at? To the left. Good. It would be around here in this location, so we circle it. This is why we write it this way. We're trying to describe numbers less than negative 4 fifths. Numbers less than this number are numbers smaller. Where do smaller numbers live? They live to the right of the number or to the left? Good. So you shade all the numbers to the what? To the left. If you kept it this way and graphed, I bet you may have put the wrong graph. So this is the right graph. How about interval notation? Negative infinity up to negative 4 fifths. What do we put here? Parentheses, what do we put here? If you look in back of the book, if you've seen this parentheses, is that okay? Yeah. Set notation. Set of all x such that, here's my description. Either of these can work. I'm consistent. I'll use the x on the left version. And so here's my graph. Put a check for the right graph. Put a check for the right interval. Put a check for the right set. And I want to say this to you guys. Be careful. You really want to give them a check for work that's 100% correct, not part correct. Because you don't want people to have that bad habit of only doing things halfway. So be strict with the grading, meaning, what if they put an infinity here, Mr. Judge, on the left, and they put a negative 4 fifths? Is that okay? No. Because what? It's negative infinity. What if they put negative infinity and a positive 4 fifths? Is that okay? No. Why not? It's negative 4 fifths. Yeah.
What if they didn't have the little set of...
These here, mark it wrong. And this is a conversation I had earlier today with a colleague of mine. This needs to be what? Set what? Notation. You got to have your curly brackets. You got to have that variable with this what? In other words, this is the framework of your answer. This is the description. So I know it kind of seems a little strict, but it's actually a good thing. That you get people with some good habits, writing the graph, the interval, and set notation, because this is the set notation. This is pretty much it. Okay, you guys okay with these two? So, anybody have any questions on these two? What about this? You guys are going to love this one. Here's what I do. I already, you know what I do? I do a double what? Translation. You go, what are you talking about? Let's take a look. We got 10 here. What do you guys notice about that negative 12?
It's positive.
Good. It's now positive 12 on the other side, right? I still have what? Less than or equal. What do you guys know about that x that's on the left? It was negative. What's it on the right? Good. What's 10 plus 12? So we have 22 less than or equal to what? X. Do you guys notice? I took this stuff from your homework. So if you have this as a solution, is that okay? Yes. What do I typically do? I write it as what? X. 22. Let me think. I'm really comparing 22 with X. I'm really comparing 22 with X. JAWS opens to what? The X, the bigger number. So your JAWS has to still open to what? X. It's still the bigger number. You okay with that? Nothing changed. Just because you switched the order the way we did, nothing changed. JAWS is still opening to what? The bigger number, which is X. And that, ladies and gentlemen, if you do this, that's a good thing. Why? Because when you go to graph, remember that, when you graph this, what do you need? 22. 22 would be there maybe, approximately, right? We labeled where it would be. Do I shade this? I have to describe numbers, arbitrary real numbers, that are greater than 22. Numbers that are greater than 22 live where? To the right or to the left?
Right.
Shade everything to the right. Here's your graph. So it comes down to that premise, that idea. Remember, the further the right you go, the larger the number. The further left, the what? Smaller. What about interval? How does that interval notation look? 22 up to infinity. What about set notation? Set of all x such that x greater than or equal to what? 22. You got graph, interval, what? Set. Put a check mark. Solution, graph, interval, set. What's our time like? We're out of time. Darn. You have to stay tuned for that one. Now, because you know what we got to do? We got to give you back your papers.
I didn't go to the bathroom.
Oh, it's in your homework. It's number 53. Here we go. Hold on. What you guys want to do, pass up that tab.